Page 138 and what is that? 139. Right.
Will it make us write greatest common
Here's
factor
all our
over
work.
again, or can we just write GCF?
GCF, definitely.
Okay.
One of the things I'll discuss. A variety of different things here that we got to cover to build up. We're building up to these problems down here, though. So each thing is kind of a part to get to right here. So we talked yesterday about factors. What are factors?
They're the numbers in a multiplication.
Right,
Not the
and
answer.
then we found factors today in our homework, where I said list all the factor, for 70, for 35, for 18, right? And we listed them all. Maybe we missed some, maybe we got them all, but those were all the different factors, right? So when you're talking about a greatest common factor, it's kind of self-explanatory. As Dominic just mentioned, it is usually represented with the letters GCF. And that's how I write it on quizzes and tests. That's how the book uses it. It just is. It's the GCF. So when you see GCF, that's greatest common factor, you will see GCF on quiz and tests. Remember, I now am writing your quizzes, so they'll be faster, they'll be more efficient, but GCF, greatest common factor.
Easier or harder?
So to find a greatest common factor, you need at least two numbers, right? Because if you have just one number, you're just listing the factors. There's no greatest common factor, they're just facts. So you need more than one number, greatest common factors here. So basically the greatest common factor, we define it here, need two or more numbers to find the greatest common factor. The GCF is the biggest number that is a common factor to all numbers. So, gotta have two or more numbers to find a greatest common. Otherwise, you're just listing the factors out, and we are going to do that. We are going to list factors out for both numbers. So once we've done all that, our next thing here is we're going to look for common factors. What are the common factors between two numbers? Numbers that divide into both numbers. Like if I said 6 and 8, for example, you probably already know that 2 is a common factor to both of those numbers, right? Both of them divide by 2. So that's a common factor. But then, once we know all our common factors, the question is, what's the greatest common factor? And we're going to solve that a couple different ways. When we get there, first we're going to do it by listing all the factors and finding common factors. Then we're going to solve them using prime factorization, factor trees. And how does that work? Okay? So looking at page 139, it says list the factors of each number, then circle the common factors for each pair of numbers. Number 3 says 6 and 9. So what I'm going to do is I'm just going to rewrite them this way like this, 6 and 9. Okay. So the first thing it says to do, list the factors of each number. What are the factors of 6?
2 and 3.
2 and 3?
And 6 and 1.
And 6 and 1. So 1, 2, 3, and 6 are the factors of 6. Yes? What are the factors of 9?
3 and 3 and 9 and 1.
So 1, 3, 9. There's the factors of 6. There's the factors of 9. Okay? Now, it says circle the common factors. So my question is, which of these numbers are factors to both? Kano.
3 and 1.
Right. Common factor, common factor. 2, 6, and 9, not common factors. Not the 6 and 9, right? So try number 4. 3 and 15. List the factors of 3, list the factors of 15, circle the common factors. And 15. List me all the factors for the number 3. Just like we did here. All the factors for 15. Circle whatever they have in common. Okay. What do we got here? Thatcher. What are my factors of 3?
1 and 3.
1 and 3. What are my factors of 15?
There's 1. There's 3. There's 5. And 15.
Mm-hmm. So what am I circling?
3. With 3 and 1.
Right. 1. Never forget about 1. Never, for whatever reason, 1 gets lost in the wind a lot.
I
But
understood that.
yes, Kena.
Isn't 1 in every single one?
Exactly. So whenever you're listing common factors, never forget about 1. People will do great listing the 3 or the everything besides the 1. They'll list them all out there for me, and then they'll forget about 1. And then you lose half a point, or you get to do a correction on it. So never forget about 1. What the greatest common factors? Try number 5. 4 and 11. Great. We're going to build up here, Charlotte. But first we need to know what common factors are. We're building to something here, Dominic. Okay, number 4. Charlotte, what are my factors of 4?
1, 2, and 4.
Good. What are my factors of 11?
1 and 11.
What am I circling?
The 1.
And that's all I'm circling. No matter what, if all else fails, I mean, numbers could be divided by 1. So there's always a greatest common factor. There's always a greatest common factor. This isn't a situation where you go 4 and 11, what's the greatest common factor? There isn't one. Well, no, it's 1. It's the only number that divides into both of them.
So when you're doing this, do you try and find the highest number possible?
That's what we're going to get to.
Okay.
Right. First, starting with common factors here. Okay, let's look at the next part, number 11. So 11 says 15 and 21. And once again, I'm going to just write it out this way here. I'm going to write 15 and 21. Directions say list the common factors for each set of numbers. Okay, 15. What are my factors? 1, 3, 5, 15. 21. What are my factors? 1, 3, 7, 21. Right? So list the common factors. So there's the factors. Now it says list the common factors. So I'm just going to call them CF for common factor. Is that fair? CF stands for common, because it says list them. So what are my common factors? Well, 1's a common factor, 3. So my common factors are 1 and 3. Okay? And then it says circle the greatest common factor. So back to the definition we go. 2 or more numbers. Well, we got 2 or more numbers. We got 15 and 21. Okay? The biggest number that is a common factor, so here's my common factors, right? 1 and 3. The biggest number that is a common factor to all the numbers. What's the biggest number here?
3.
3. The greatest common factor between 15 and 21 is 3. It's got 2 common factors, 3 and 1, but it's got 1 greatest common factor. There's only 1 greatest common factor. 1 and always 1. There's no such thing as greatest common factors. Does not exist. There's one and only one greatest. Just like there's only one first place, right? There's no such thing as two first places. It's not a thing. There's a second place and a first place. No, there's first, right? So there's one greatest common factor. So once you know all the common factors, it's just the largest value you have in front of you. Try number 13. So same deal. 12 and 72. I want you to list the common factors, but to list the common factors, you're going to need to list all the factors out first. So you're going to have to do this again. You're going to need to know all the factors. So once you have all the factors, then tell me what the common factors are, and then circle the greatest common factor. What we're going to use greatest common factors for, especially when we get to our next chapter, is we use them to simplify our fractions. If I have 6, which I think a lot of people understand as 1/2, but what I'm really asking is, what is the greatest common factor between 3 and 6? And you would say 3. That's the largest number I can divide into the numerator and the denominator. When I divide the greatest common factor into my fraction, it will be simplified 100% of the time. When you divide by, that's what we're going to need to do. So that's, and we have to endlessly simplify things with fractions. You guys know that. Always have to simplify. Yes. But to understand anything, simplifying what goes into what, how do I do this, you need to understand what a greatest common, and understand what divides into what. If you can't do that, then you can't, I mean, how are you going to simplify a fraction if you can't figure out what divides into anything, right? But again, we're in 5th grade. We're working with 1/2 and 2/4 and 3/6. So it's about the concepts. The math won't be crazy hard here. It's more about, okay, I understand how this works. And then if when the numbers get bigger, you're like, I know how to do it. It's just going to take more time to do the math, the multiplying and adding problem. Whatever to solve it. But this one, there were a couple of interesting things here. So for 12, there's a lot of factors here. All of these are factors of 12. But here's one of the interesting things. If you are able to see it or recognize it, maybe you know that 12 goes into 72. Goes in 6 times. 12 times 6. Should be one of your factors down here. But why does that matter? That matters because all the factors of 12, all 6 of these right here are also factors of 72. Which means this really speeds up trying to figure out all my factors of 72. Because every single one of these numbers goes into 72. If this number goes into this number, then all the factors of this number have to be factors of this number too. Plus more, because 72 is bigger. So I'm going to have more factors. But for 72, 1, 2, 3, 4, 6, and 12 are all factors. 1 times 72, 2 times 36, 3 times, what is it, 24? 3 times 24, 4 times 18, right? Yep. 6 times 12, there they all are. So there are,
I got 9 and 8.
these are all the factors of 72.
What about 9 and 8?
And 9 and 8. Yeah, but that's a lot of factors. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 factors to the number 72. Well, it is, but two things I'm trying to illustrate. One, all these factors, if you knew that all the factors of 12 are factors of 72, that's how I found a lot of these missing numbers. 2 times 36, 3 times 24, 4 times 18. So that's how I was able to get all of them so fast, because I already know these all have to be factors of this. So then it's just a matter of 72 divided by 2, 72 divided by 3, 73 divided by 4, 72 divided by 6, which is 12. And then 8 times 9 on top of that. So anytime, if you ever recognize this situation where this number is a factor of this number, then all the factors of this number will always be factors of the bigger number too. Okay? So then if we circle them all and list the common factors, there are 6 of them, right? All the factors of 12 are what the answers are. That's the common factors right there. And the biggest one, of course, is 12.
Wait, what?
12 is the largest number that divides into both 12 and
But what about
72.
72?
That doesn't divide into 12.
They don't have.
What matches on both? These are the matches.
Oh.
These are not matches. They are not common factors. Common factors are factors that are common to both numbers. Right? So none of these divide into 12. But all these numbers, 12 divided by 1, 12 divided by 2, 12 divided by, right? 72 divided. So the biggest number, that's what I'm asking. That's what the greatest common factor is. What is the biggest number I can divide into these two numbers? The answer is 12. 12 divided by 12 is 1. 72 divided by 12 is 6. If this was a fraction and I said simplify that, you'd work it out and go, greatest common factor is 12. I divide both sides by 12. Simplified, it's 1/6. That's where we're going with this. Ultimately here, that's what a greatest common factor does. Try number 20. I told you I'm going to talk about 13 again after this one again. So this time we have 3 numbers. And that's okay. So what do? Well, this time I'm going to same thing I've done before, except I'm going to make 3 little rows. I'll list all my factors of 4. What are my factors of 4? 1, 2, and 4. What about 8?
1, 2, 4, and 8.
What about 12?
1, 2, 3, 4, 6,
And 12. So there they all are, the factors. So when I say, tell me the common factors between 4, 8, and 12, I need it to match on all 3 lines. Like 1, of course, will, right? So 1's a common factor, but what else? Are there 2? Because I got a 2. It has to be on all 3 of them. If it's not on all 3, then it's not a common factor. Any others? 4. 1, 2, 3. And that's it. And of course, the greatest common factor would be 4, right? The biggest of all the common factors. So if there's 3 numbers, that's okay, no problem. It just needs to be a match for all 3. If it doesn't match all 3, then it's not
So
a common factor.
not more than 1 is always the LCF.
Right, the GCF.
The LCF, because least common factor.
Sure. It's the greatest and the least, because it's the only one. It's singular. Yes, then it would be the LCF. Sure, why not, Dominic? Okay, so we're going to do 22. It says find the greatest common factor, but I'm going to cycle back to this here. And this is ultimately what this lesson's about, what we're about to do now. So this is why I said, Emma, you might have to watch the video tonight, because now I'm really going to show you what we're doing. So I'm going back to 13 here. We did all this, and like you said, I heard a lot of you say some of these numbers here were just not part of your set, were they? Right? 72, 36, 24, and 18. Anybody get all four of those? And then even at the end, there was old Mr. M. What did I forget? I forgot about 9 times 8 at the end. Heavens to Betsy. You guys missed some of these. I missed that. We all missed something.
No, I got them all.
12 numbers. You got all 12?
Yeah.
Kana got all 12. Kana is superior to all of us in every regard,
What?
especially hair
What?
length. Her hair length is surpassed. Well, maybe not. You guys are close on hair length. Who has the longest hair? Of you three? Emma does? Kana does?
And then probably Emma and me. Yeah.
Okay.
Track is over here.
You can pull out a strand and we'll measure it with rulers.
Yeah.
Get out the yardstick. Sounds like a study hall activity for tomorrow. Okay, back on track. So where I'm trying to go with this is we found the greatest common factor of 12. We listed all these factors, but it wasn't really an efficient method. It's quite possible you didn't even get 12 as your answer. I don't know. But at the minimum, this took quite a while, right? Just to get this number. If only there was a faster way. So, and I am going to cycle back to this problem here, but let's look at 22. So it says find the greatest common factor. But this time, we're going to use factor trees to do it. Instead of listing all the factors, then listing all the common factors, and then finding the greatest common factor, we're going to do it a better way. Because, again, if I said, what's the greatest common factor between 256 and 308? Is it going to be practical to list all the factors of 256 and 308 out?
No.
Absolutely not. Are you possibly going to miss some?
Oh.
Probably. Because I don't know all the factors of 14 and stuff off the top of my
What
head,
happens
and
if
nor
we
do
get
you.
small numbers then? Would we,
Huh?
what would it, if we got small numbers like 4, 11, and then?
So what I'm saying here, what I'm trying to tell you is that perhaps listing all the factors out and doing it this way, it works for this lesson. But if I start jacking the number sizes up on you, you got no shot. You don't know all the factors. I don't either. I have no idea what all the factors of 12,822 are. I don't know if there's 4 of them, 14 of them, or 44 of them. Off the top of my head, I don't know. So what I'm trying to say is, though, if I have to find a greatest common factor involving that number, I need a better strategy than listing all these factors and circling stuff. Hello, factor trees. Hello, factor tree. The factor trees will let you break down any number and find the greatest common factor much faster. Doesn't matter how big the number is with factor trees. So 45 and 60. Okay.
45. Why did you put them so far apart? Yeah.
Because I need to build 2 trees.
Oh. Whoops.
I need to build a tree for 45. I need to build a tree for 60. And I am going to build the trees. 3 and 3. 12 and 5. 4 and 3. 2 and 2. Okay.
I have to go.
Yes, I understand, Emma.
Do I have to watch the video?
I probably would just because I did my best to finish.
Yeah, that was just right.
It'll only go for like 10 more minutes. Okay. So there we go. I built my trees. I'm rating things out in exponential let me think here. Hold on. I gotta think about it. No, that's not what I want to do. Skip that. This is least common multiple. Okay. So what I'm going to do here, you see, I'm going to write it in what I call expanded form. This is that tree over here,
Cool. I haven't even started 60.
and that's that tree over there.
Can't you get 60 with 6 times 10 too, though?
Huh?
Can't you get 60 with 6 times 10
Yeah.
too? Would that work too?
Yeah.
Oh, well, that's what I'm going to do.
Well, 10 and 6, 5 and 2, 6 is 3 and 2. That's the same 4 numbers right there.
Yeah.
Just in a different way. So I've done prime factorization to both numbers. Would you agree with that? There's 45, there's 60. I am not writing an exponential form.
Yeah, good idea.
When we do least common multiple, we're going to have to do this again, but we are going to write it in exponential form. And I told you at the end of the tree is we interpret them differently, depending greatest common factor or least common multiple.
Looks like 60, and 45.
So what does voting a tree have to do with the greatest common factor?
Right, well, that's what I'm showing you. That's what's coming now. So, how do I get the greatest common factor out of this here? Here's what you do. You are looking for matches on both trees. What do they both have in common?
They both have a
They
three.
both have a 3, and they both have a 5. So, I got 3, I multiply those numbers, what's 3 times 5?
15.
Which is my greatest common factor. The greatest common factor between 45 and 60 is 15.
But this is
It's the largest number that divides into both.
assuming we get the tree right.
Now I see where you get the 3 from, but why didn't you do 3 times 5?
Because there's a 5 on both trees.
Oh!
This is 3 times 3 times 5. This is 2 times 2 times 3 times 5. What do they have in common? They both
3
got a
times
3.
5.
They both got a 5.
Oh!
So it would be
And all you do is multiply whatever's in common to both
What would
trees.
you do if you had 3 multipliers?
I'd multiply times that.
Oh.
Whatever I have in common. If I only have one number, like just pretend I had 3 times 2 times 5 over here, and over here I had 3 times 7 times 11.
So
Why did you get
Well, then the greatest common factor would be 3.
So are the common factors in this just 3 and 5?
Multiplied
15?
together, 15 is the greatest common factor.
Yeah, what's all the other common factors?
We don't really care. We just care about the greatest common factor because that is the singular number. Again, what I'm doing is pretend this is my fraction. I say simplify that. If I divide both of these numbers by the greatest common factor, I get simplified right there. The greatest common factor is the biggest number I can divide into both. When I divide by that greatest common factor, my fraction will always be simplified. That's it, done.
answers, but only one was
Right. I don't even know if you'll see a fraction this big this year, but still, it's the same thing. This is 3/4 simplified. I need using greatest common factor to simplify. Right. So let's try number 23. Use your factor trees.
No. Do we have to for the homework though?
I'll look at it in just a moment here and tell you my expectations for you. So 24 and 40. So on the homework here, 1 through 4, you list all the factors, then you list the common factors, then you write the greatest common factor. Pretty self-explanatory. The second part, again, you'll need all the factors, list them somewhere else, but in the homework, they just want you to give them the common factors, circle the greatest common factor. Finally, 17 through 27. Here we go. This is what I'll tell you to do. On the odds, you can do as you please. The evens, though, do trees. And I'll also tell you one more thing here at the end. The truth is, finding greatest common factor, there's a third method out there that's even better than both of these combined
Why did you
times a
teach us
gazillion.
this one?
The third method is that you just can see it in your head without doing anything. You can just see 45 and 60 and you just know it's 15. You can see 6 and 8 and just know it's 2. You can see 12 and 20 and just know it's 4. So, but to get to that level, you need to be very, like Dominic, I think you're already there, and then some. I mean, you don't need tree, but numbers are going to get bigger. As I said, if I said 256 and 3, I can't do that either. I'd have to do a tree. I wouldn't want to list the factors out. But I could do a tree, and I would do a tree, and I still would do it. I endlessly can do trees. The trees are, if it's just so big, it's like, but in 5th grade, you're not going to get it much, but you need to know how to do the trees and interpret the trees for when eventually you run into something that you can't just see.
If I can just do it all in my head,
You got to do the trees on the even, but the odds you don't have to list. The odds you can do however you want. I'm saying if you can mental an odd, consistently getting it right, cool. If you can't, and you're happy you're doing tables, then do tables for the odds. But you got to do the trees for the evens. I need all of you to be able to do trees. I have to have you be able to do trees for when the numbers get bigger. But truth be told, best of all is that you can just do it in your head because your math skills are of that caliber. But that's not the story. Not everybody's to that level. That's the thing, Dominic. Some are there, some aren't. I gotta teach to all of you. We're not done yet. We're
I
still doing
finished
this.
the tree.
Okay, so really there's three methods out here. Listing the tables, list the factors, find common factors, find greatest common factor. It's a method, it works. Method 2, prime factorization. Great method. Works for bigger numbers. Works for any numbers. Method 3, mental math. That you understand factors. You can do a lot of mental math in 5th grade here just because the problems are designed to be that you understand how to build
So
trees.
all the odds we do in our head or use.
I'm saying 1 through 16 do as normal, 17 through 27. That's find greatest common factor. 18 through 26. I need trees for 18, 20, 22, 24, and 26. At the minimum, I need 5 trees. If you want to do more trees or I don't care how you get the right answer for the odds. You can mental math it, you can table it, you can build 5 more trees. You decide. You make the call. Just get the right answer.
So which one do you?
You decide which of the 3 methods. I wrote it down. It's right here.
So you want us to do that
Oh.
on the homework?
On the homework, make sure you have a minimum of 5 trees. 18, 20, 22, 24, 26. The other 5, 17, 19, 21, 23, 25, 27, you decide yourself. I've shown you 2 methods, and the third one's mental math. You just know your tables well enough in your head. The numbers are of small enough caliber that it's not an issue for you. Okay? All right. Back to it. 24 and 40. So 24, I'm going to break it down to 6 times 4. I'm going to turn that into that. 6 is 3 and 2. 4 is 2 and 2. 40, I see 10 times 4. I see 5 times 2 over here. I see 2 times 2 over there. So what do they have in common? Well, they each have a 2. They each have another 2. They each have a third 2. And that looks like about it. That's a 5, that's a 3. So what do I have? 2 times 2 times 2. 2 times 2 is 4. 4 times 2, the greatest common factor is 8. The biggest number that divides into 24 and 40 is 8. There's my trees. What do they have in common? They both have 4 numbers, but 3 of them are 2s. So there they are. There's one of my 2s. There's another 2. There's another
I
2.
forgot to multiply the two.
There's a 2 right there. There's the 2. There's the 2.
Okay.
One more.
No.
No.
Last one.
Okay, just
Number 30. Solve it using trees. 12, 15, 18.
So what now? There we go.
Greatest common factor, solve using prime factorization. Same thing as the tables. When you get to the end of your trees, whatever you're multiplying and all that together needs to be on all 3 trees. So whatever numbers you're taking to multiply at the end, it needs to be on all 3 trees. Fear not, most of our lessons aren't going to be quite this long. Once in a
I'm
while.
starting homework.
It's kind of a heavy start to chapter 4, but it slows down in a big way here soon. So soon it'll be back to our normal pace, I suspect. All right, so 3 trees. Okay, well I'm just gonna start my trees.
I'm not done yet, though.
Okay, I'll just wait. I
I'm
will-
only on 18. No, GCF. Oh, no, No.
Honestly, of the methods, the tables is probably the lowest effective because it's a limited use. The number's got to be pretty small for it to be a viable option, but also, like we saw 72, you're prone to missing numbers.
Oh yeah, do you want these?
With prime factorization, you don't have to worry about thinking of all 12 factors of 72.
Do you want these now?
Sure. So that's another huge benefit.
Do I need my name on this or?
Nope. No. Oh, sign looks good. This looks good, Thatcher. Thank you. All right. 12 breaks down to 4 times 3. 4 breaks down to 2 times 2.
I did 6 times.
2 times 2 times 3. 15 breaks down to 3 times 5, and that is it. 18 is 9 and 2. 9 is 3 and 3. That's 2 times 3 times 3.
And that'd be 3 times 3 times 3.
That would be 27.
Yeah, that's what I thought it was.
12, 15, and 18.
Oh, I did them all as 3 separate problems. You're supposed to.
12, 15. So now what do they have in common? 2s? No. 3. I see a 3 here, a 3 here, a 3 here, another 3, another. No. It's the only match I see. So therefore, the greatest common factor between 12, 15, and 18 is 3.
What? Why don't you multiply it together? You multiplied all the 2's together in the last one.
Because I pulled 3 2's out. 1, 2, 3, 1, 2, 3. Whatever they have in common. But these only have one number in common. There's only one number they have in common. If there was a second number they all had in common, I'd multiply it times 3. I only multiply the numbers that they have in common. If there's only one number they have in common, then there's nothing to multiply. What if I go through it and they don't have anything in common?
Well, 1.
Right, like if I said use trees and what's the greatest common factor between 11 and 6, and you go 11 and 1, 3 and 2, no. Well, technically I could draw a 1 right there. Anything times 1 is itself. So there's the match. Normally I don't write the 1 now, but as I said, there's always a greatest common factor. So even if you were doing trees, here it is. Okay, we are done. You must go. It is